it's an insulator. So why would you use that to improve your electrical connection? Give it another go. There we go. 60. So there's a hell of a big splodge on that of copper grease. Oh, what about ye? Well, somebody sent me a wee message saying I keep referring to this red rubber grease as silicone grease, and in actual fact, there's no silicone in it. Well, that's right, because there's silicone grease there, but that's just the nomenclature, and it's a pretty commonly termed as that. But yeah, we'll just talk a wee bit about greases here. So these are just some different types of greases that I have about the garage. And clearly, these are the ones that are readily available to me that my local auto parts store stocks. So you can get different variations. There's different formulations, and you might get different manufacturers stating, you know, that'll do this and it'll do that, and other uses and all that sort of jazz. So everybody has preferences. You know, with experience, you use it. But this video here is about the main reasons and the main purposes of all these different types of greases. Very quickly, we're not going to go into this too much. We're not going to go into the makeup of some of this stuff. So a lot of this stuff you'll probably know, and you use it yourself, and it's pretty self-explanatory. Some of it not so much. So that's CV lithium moly. That's lithium disulfide grease. That's the black stuff, and yeah, there we go. So obviously used in CV joints. That's what it's advertised as, and yeah, use that on forcing screws and stuff like that. So bearing pullers and stuff like that. So the idea of that is if your surface of your metal isn't smooth, and it's to fill in and it's to make it smooth. So ideal for a forcing screw, that is the recommended stuff to use for that. Petroleum based. So the main difference between these greases here is whether it's petroleum based or it's natural based or maybe synthetic. Copper grease advertised with 8% copper in it, and clearly the brown color that we all know, used quite a bit, misused as well. No brake pad manufacturer recommends using that on the back of their brake pads. And you don't use it nearly anywhere in a brake setup. I use it sometimes just to prevent a bit of rusting on carriers, but that will swell rubber really, really bad. Don't use that for slider pins or anything like that. But there's copper in it, so it could make a pretty good contact grease. Well, so you would think, but we're going to talk about that a wee bit later on, about contact grease. This is burn grease. High performance, a wee bit thicker than the usual multi-purpose stuff, and higher temperature. Again, petroleum based, easily recognized because of the yellow color, petroleum based. I do not have petroleum jelly or Vaseline here, and the reason is because I don't use it. That is a very, very low melting point and isn't good with rubber or plastics. Do not use it on connectors. It'll melt that wee rubber seal, and if it gets into the contact there, if there's any arcing going on or whatever, it can actually ignite. So no good. Multi-purpose grease. That's again the petroleum based yellow stuff, and it's just general purpose, but no good for rubber or plastic. In the spray tin there is white grease. Now you can get a lot of lithium based white grease. This one here is calcium based, and there's polytetrafluoroethane in it, PTFE, which is very slippy, and it's Teflon basically. So that's the white plumber's tape that you see and stuff like that. This one here, I don't really use as a big lot. We use it in hinges and stuff like that, but it's because it's white. There's a thing about a lot of these greases that have dye in them, and it's basically to show that the thing has been greased a lot of times. Now, whether the white is the calcium and the PTFE or it's deliberately white or not, but you can get lithium grease. Lithium grease, I don't use lithium-based grease at all because it goes very hard, but this stuff here goes very hard as well and ends up caking up, and you know, it's like candle wax then. So I don't really use a big lot of that. Silicone spray is just a silicone grease in a spray form. This is silicone and not silicone, and yes, sometimes that's referred to as silicone, especially me, but it's actually called red rubber grease. There's no silicone in it whatsoever. It's made from natural oils and inorganic material. So there's no petroleum, no hydrocarbons in it, and it is especially used for, there's even a picture of a brake caliper there on it, and it's the same as you would get in these wee boys here. So there's a brake kit which has red rubber grease in it. I've done loads of videos where I've said use this red grease for anything that has rubber or plastic components, and yeah, that's it. I was using it to hold up a fuel filter seal, and I was basically just using this stuff here because it's so sticky and it's so tacky, you know, so it was just basically to hold the seal in place for me. But for those keen-eyed in that particular video, they would have noticed, well, that was a diesel filter, and there was hydrocarbons. The diesel is a hydrocarbon, so you know you didn't really have to use a non-petroleum based grease because the seal would have been, you know, resistant to hydrocarbons anyway. So below that is a tin of silicone grease, and that is a tube of silicone grease, and that is, of course, silicone based. It is clear. There's no dye in it. Oh, incidentally, the reason why that's red is because there's a red dye in it. But we'll see there's a red dye and that stuff there as well. And I'm going to show you a wee bit of this stuff here. But the silicone grease, then it is actually marketed that it's rubber friendly. So lubricates and protects plastic and rubber parts. And that's why we use that. That is a higher temperature, withstanding temperature, than the red stuff, the rubber grease. However, it is really, really good as a moisture repellent. Now, some people, and there's certain formulations and certain manufacturers, would advertise this as dielectric grease, and some people then would say, oh well, that's a contact grease then, use silicone grease for that. But for the next part of this video, we're going to talk about contact grease. So I'm sure you hear the term dielectric grease, and I use it myself as well. And over here to the right, we have some which is actually marketed as compound or switch contact grease, and this here is industrial switch electrical contact lubricant slick switch there, which you won't get that in an auto parts store. This stuff here is again switch contact. Let's say switch contact lubricant. So you notice the way it's not saying grease there, because it's a bit thinner than grease, although that is very like a grease. And this stuff here in the aerosol is by the same manufacturer. This company that makes this is made by Fuchs, and it's marketed as this Lubritech Limited, and they only actually do those two products. That's it. But this is power isolator lubricant from Lubritech. So I'll give you a wee look at that. So there's a red dye in this stuff, and the idea of that is that so that you know that the grease hasn't been washed off, and that is the purpose of the red dye. It's just a visual. It doesn't really serve any purpose other than that. So you can look up at your apparatus there, and you can see whether all the grease has been washed off or not. So I'm sure there's a lot of opinions on the interweb of a lot of this stuff is marketed with the word dielectric in it, and they would use that to improve contacts of electrical connectors and stuff like that. So this magic word dielectric is bandied about, and well, sometimes I think it's maybe misunderstood. Basically what a dielectric is, and I'll draw a wee diagram. This is a capacitor, And that bit there that's in the middle is known as the dielectric. So it's an insulator. So why would you use that to improve your electrical connection? Similarly, any conductor that has an insulator medium on it, in this case here it's PVC. PVC will have a certain dielectric strength, and cross-linked polyethylene will have a certain dielectric strength, and the dielectric strength of this medium, it may be mica, it may be impregnated paper or whatever, it will have a certain dielectric strength, and that's how good it is as an insulator. However, if this was a complete insulator, then that capacitor would be just open circuit. So the dielectric will actually polarize at a plus or a minus, depending on the direction of the current and the magnetic field it builds up, and then it will energize the electrons in here and they will cross over. So it will actually conduct. See, in this particular brand here at the bottom, it actually does say excellent electrical insulator in this silicone grease. Grease around an electrical connector. So what it's really good for is to help with this rubber seal here. So if we put a wee bit of this silicone grease around it, a splodge around it like that, that will help with that getting into the connector, and it will repel moisture, and it will really, the best seal that you'll get there. Now, if you do put a wee bit on the connectors, then that's no big problem. Even though it's not really conductive, it will prevent the connection itself from oxidizing, and that's what contact grease does. Well, it's not really called contact grease. It's called contact lubricant. So this particular stuff here comes in this tube here. If I can get it off, it's like one of them toothpaste dispensers. If I pull that wee thing out there, this is, it's like silver paint, and that's because there's 10% aluminium in that. This stuff here is for moving contacts. So if you imagine that switch open and closes, it makes a contact. But you're doing that in your connector. You're moving a connector in a female part into a male part. So whenever you put some of this, look at that stuff gets everywhere. Whenever you put some switch lubricant, contact lubricant in your connection, most of that grease it gets pushed out of the way. But what you're really doing there is preventing that from corrosion, preventing that contact from oxidizing and all that. In a car, you have the rubber seal around it, and the bit of silicone grease keeps the moisture out, and all that. So it shouldn't really oxidize. You can put a bit of some of this stuff, and I do use this stuff here all the time. But there's one major aspect that you need to watch when you're using any contact compound, and we're going to prove it in a wee minute. But if we read the back of this, there's a very important statement: apply sparingly to any dry electrical contact, fixed or moving, blah blah blah. There minimizes voltage drop across contacts, moisture repellent. So that's the main purpose of this. It really doesn't improve the connection. It's a preventative of the connection. And if we'll look at this stuff, this is black and it's quite sticky, this one, in comparison to the silver stuff. And this one here is a really old tube of stuff, which I use in engine bays, and I can't get any information on that at all. If we take a bolted connection and a copper bar, and the surfaces are clean, free of oxidization, and you bolt it together, that should be as good a connection as just a solid bar. However, if it's exposed to the weather or moisture gets at this, and this starts to corrode and starts to oxidize, then the connection can start to break down, and that's what we're trying to prevent. Well, so far you may think that's all well and good. That's just conjecture, opinion. I've been using this stuff for years and it works great and all that there. Can you prove any of this? Well, I am. I'll introduce you to this thing, which isn't mine. I've got a lend of it. It's very expensive. It's about £6,000 to buy this. So this is a micro ohm meter. So this is going to measure in micro ohms. This is what's inside that box. So it looks like an ordinary megger, but it's a brief bit thicker. This thing's full of capacitors, and it's going to pass a current through this, and what it's for is to test a connection. So it's to see if there's any resistance in a connection, and we have two probes, and we can push it down either side. These probes are spring loaded, and you need to have the surface clean, of course, of any oxidization. So we'll give it a quick burst here. So we've been lucky enough to get a land of this in the name of science, but unfortunately I think this wee trigger, which is the test, is a bit dodgy, so I might have to reach over and press it with my finger. So we'll have a wee look at this copper here first of all. So we just scraped a wee bit of the oxidization layer off in certain places there, and the trigger's not working, so I just have to hold it there and hit it with my pinky. And we're getting 10 microohms there, and it's put 50 amps through it. So if I go down a wee bit, let's see. And that's 18. And that's just basically because there's more material for the current to go through. So, you know, there's just more resistance there, and that is in micro ohms. Similarly, if we put the probes very close together, well, we trigger works now and again. It's a bit dodgy, and we're down to 6 as the probes are close together. Here's a piece of aluminium, different material clearly. Trigger's still not working. And that's 62. Maybe it wasn't on right there, so give it another go. There we go, 60. So what I'm going to do, I'm just going to lay one piece of copper on the other, and we'll have the surfaces deoxidized, so there's nothing in between it at all. And we're just relying on the weight of me pushing down on this to make a contact. If we use the bolted together connection, because these bars are so short, it'll hardly make much difference, the contact grease, because when you bolt it together and you clamp it together so tight, you know, it just squeezes the grease out, so it doesn't really make any difference. But this experiment here, where it's not bolted together, we will be able to see the difference that the contact lubricant, I should be really saying, makes. Okay, so we'll give this a go, and no, our wee trigger's not working, so we'll have to press it manually. So we're up on 46. So even though the distance is only between there and there, we'll have a bad connection here. We'll give this stuff here a go first. There's nowhere in this packaging where it says that this is a dielectric grease, or to use to improve an electrical connection. So we'll put a good old splodge on it there on the interface, and we'll see what difference that makes. So you can see the lubricant there. It's the friction is reduced. It can move about a lot freer. So we'll put that there. No, our re-trigger's not working, so we're way up to 224 microohms there. So that's made it worse. However, I don't know where this will work or not. I haven't tried this. So what I'm going to do is I'm going to do a repeated test. We've still got the silicone in there. I haven't touched it. 224 is without that. But if I pass current through it multiple times, that will start to polarize so it'll start to charge. There will be an electrical charge in that silicone grease there. So that's a theory anyway. So I have to keep that sort of propped up so you can see it, and we'll give it another go here. So the value should get less the more current I put through this. I'll have to wait till it charges up again. So it's improving slightly there, as we can see. So there we go. I think that's all we'll do on the silicone grease. So we'll take that off and I'll give it a weight down. Right, we'll put some of this stuff on, and this is the stuff with 10% aluminium, and it's really messy. And we'll put a big splodge on it. We'll put far too much on it here. So there's aluminium in this, so we're going to see what that makes. And right, here we go. Here we go. Right, so it's definitely sliding about a bit there, a bit freer, and we'll give that a go. $44. So vast improvement on the silicone. 39, we're charging it up. 37. So instant improvement, and there's 10% aluminium in that stuff. Next up is our old copper grease. Now, there's copper in this, so you don't want to make that in contact with aluminium components, and that's why I have this stuff. This is for, there's aluminium in this, so this is for aluminium. So you can get galvanic corrosion occurring if you put copper grease onto aluminium. So that's just a thing to keep in mind. This stuff, as I said before, has 8% copper in it, according to the manufacturer's data sheets, and it's commonly used as an anti-seize. So this is petroleum based. It's not rubber or plastic friendly, and it's mostly used as an anti-seize, and it works quite well as an anti-seize. I've seen experiments done, and it comes out pretty well. It does what it says in the tin. There's actually soap in that as well, so we'll get a bit of that splodged on. So there we go. There's a hell of a big splodge on that of copper grease, and yeah, it's not as slidey as some of the other stuff there, I can say. So yeah, okay, we'll give it a go here without further ado. $50 microohms, so it's went up. What's that? 11.2. So it's conducted quite well there. 218. So I don't know where that 11.2 came from. Try it again. 208. All right, we're getting more consistent high readings here. 340. It's actually getting worse. 284. 183. Starting to charge up. Now, there's 178. Now, the big problem here is I have far too much of this on this, and that is a problem with when you're using contact lubricant. If you put far too much on it, you actually make the situation worse. So you've got you're making it into a capacitor. So you don't want too much. As it said on the wee tube, and this was the big important thing, was apply sparingly, and that is the key to all this. So I'm just gonna, what I'll do is, we'll take a wee bit of that off and see if it improves it. So just a smear on here, and well, I'm gonna go with this again here. See what happens now. Well, our wee button's not working again, so there we go, right down to 67, 63, 65. So pretty consistent results there. 68. Oh, that's I have to wait till the capacitors charge up. So when the wee padlock comes on the screen there, that's the capacitors charging. 72. So in around 70 there, as opposed to a couple of hundred from too much grease on it. Okay, for our last test, we're going to apply some of this stuff. This is electrical contact lubricant, it says there, and this is for moving contacts. So this is more of, to provide an ease of the contacts coming together. I don't think it's really, I don't think there's any metal on it, like the way there is with copper grease or with this other stuff. So I think the key is to apply sparingly again, but we'll just see what the numbers are here. So it is very like a mechanical grease, and has the consistency of that. So yeah, we'll get a wee bit on the copper bar. So here we go. And I haven't said contact in any of this, which should be doing. This is very slidey, so yeah, it's a good lubricant for sure. And we're away high. Oh, it's charging up rightly. 94, so it's up and around the 100. So it is worse than copper grease, and that's because copper grease has copper in it, So copper grease isn't too bad as a contact lubricant. It's slightly better than this stuff. But yeah, so what do we conclude from all this? Well, no matter what it is, you use this industrial product that's specifically designed for moving contacts. If you put too much of anything in between your contact faces, you're going to have a capacitive effect, and it's going to have to charge it up. So you want that to be a very, very, the word sparingly on the wee tube there is the important key here. So this stuff here, the real thing about this is a lubricant. So it helps with the contactor moving in and out. So it lubricates it, and it prevents oxidization. So whenever your contact is making, whenever that's making that contact probably pushes the most of that sort of, the grease out of the way, but it prevents the oxidization and the moisture from getting into that contact area. So, so the key here is that you don't want to fill that up with anything at all, because you're creating a worse connection. So that's my takeaway from doing this wee bit of experimenting. And yeah, we can see that definitely some stuff's good, some stuff's not so good. Silicone isn't really the answer to make an electrical connection, and even contact grease, it's not a full conductor, so it's still going to, if you have a connector packed with anything at all, it will inhibit it'll increase the resistance, but you're relying on that connector to push that away. But you're trying to keep moisture out, you're trying to stop it from oxidizing. That's really what you're doing. And look at that, that silver stuff just gets everywhere there. So yeah, so okay. Comments are open. You know, everybody can put in, this is what I use and this is what I prefer and blah blah blah. And you know, or maybe you're wrong about this, or there's other stuff in the market that claims this and that and the other. This is just an overview of some of the things that I have and I use all the time, and the, you know, the main takeaways from some of these products. You know, the big thing is that even if you have some of this stuff here, you know, and this is for use with aluminium. So you might actually see on aluminium gearboxes some of this silver stuff on the nuts and stuff, but in it from the manufacturer. So the OEs, they actually do use stuff like this, and that's why I have this. So yeah, the main takeaway, as I say, is you don't plaster this stuff on an electrical connection, because you only make it worse if you do that. And that is the big conclusion out of all this. So there you go. Many thanks for watching, and all the best. Bye.